Welcome back to our treatment of ray diagrams. Last time we left off with a concave mirror from case 1. One thing that we forgot to do was to formalize what the conditions are when we were in this case 1 where the distance to our object was less than the focal length. Notice that our image here, whether it was from the rough sketch or whether it was from the calculation, ends up doing a few certain things. First of all, it is upright. Okay, and upright means that the magnification is positive, or you can look at it as the height of the image is positive because it's not upside down. Next, it is magnified. And an image is magnified if the absolute value of the magnification is greater than 1. Okay. Also, it is behind the mirror, so it's in the virtual world. And being in the virtual world means that the distance to our image is negative. As far as location is concerned, that's all we've got, is that it is going to be back here someplace. Now, it could, if we were to move our object right up here, okay, notice, if I'm close or if I'm far, my parallel ray is always the same, and my image is going to be found somewhere along that parallel ray. So it could be right behind the mirror, it could be very, very distant out behind the mirror. That is going to depend on where it is located with respect to the distance between the mirror and the focal point. If it was right up next to it, if my object was right in front of the mirror, my parallel ray would still be true. My central ray would be lower, and so I would expect that it is closer, but it's not going to be right behind the mirror. It's going to be some distance out here, and personally I'm suspicious that that particular trade-off location might actually be at the focal point, which would be a good follow-up calculation, but not for right now. We're going to move on to the second case with concave mirrors. Case number 2 for a concave mirror. Concave mirror, case 2, is going to be when we put the object between the focal point will be closer than the distance to our object, which will be closer than our central point. Okay. So for that one, and I know we're going to be below the axis of symmetry, so I'm going to make sure that guy goes right down the middle of the page. And this is a concave mirror. Everything, I know the interesting stuff is going to be on this side, so I'm going to move this closer to the right-hand side of the page. And let's see, how about right there? That looks pretty good. I'm going to have to sharpen this pencil before the next time. This is behind the mirror. Let's see, count boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 again, so 9.5. 1, 2, 3, 4, 5, 6, 7, 8, 9.5. Right there is my focal points. Focal point, center point. My object is somewhere in between them. Okay, I'm going to put my object right there. It's 4 boxes tall, not too ostentatious. Okay, first ray, parallel ray. Straight in, straight through the focal point. Now, if you wanted to, you can have some stuff coming from back there. Turns out that's not going to be necessary. Our next ray that we're going to draw, now that was our parallel ray. Our next ray that we're going to draw is my new favorite, the one that goes through that midpoint there. So it's going to come down 1, 2, 3, 4 boxes down. It's going to go from here to here. it's going to go from there to there. And it looks like I've got an inverted real image. Okay. That was my midpoint ray. Let's do at least one more. I really do not want to do the line through the center point because that is way the heck up here on this mirror. It's even off the mirror, okay, which would work, but it's so far away from the central axis. It's not going to agree with anything. As a matter of fact, I could line it up right now. And, oh, bizarrely, it actually is giving pretty good results. So maybe we'll draw it in. But let's draw the one through the focal point, which is also getting pretty far away from our axis. And I'm not very crazy about this particular one, because it does not agree with my other two. If you get three that all agree with each other, that's great. Now, right now, I know it's somewhere in this area. If I did one more just for grins, maybe the center point one, because I did notice that the center point one really did line up pretty well. Now, that's going to go from my object out to the mirror, which it doesn't even hit, but it's going to bounce back and come back through here. Now, personally, if I've got three lines that are all hitting one point, I'm going to ignore the one that doesn't agree with them. All right. So I'm going to go with this one, and I'm going to say that it is right here. And we're going to verify this one this time with a quick calculation. So we need some measurements. First, we start off with our distance from our mirror, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 boxes away. So the distance to my object is a positive 15. The height of my object is a positive 4. The distance to my focal point is a positive 9.5. We would like to, at this point, locate where the distance to my image is. And 1 over the distance to my object plus 1 over the distance to my image is equal to 1 over my focal point. 1 over the distance to my image is equal to 1 over the focal point minus 1 over the distance to the object. 1 over 9.5 minus 1 over 15. Time for a calculator. I'm going to just hit the inverse button this time and spit out the final answer. My process for inputting this thing, in case you were curious. 9.5, 1 over that, minus 15, 1 over that, equals, and that's what the inverse of this is equal to, so I'm going to hit the inverse again, and I get 25.9, or roughly 26 boxes out. 26 boxes out is where it should be. Let's figure out how tall it should be. Magnification is equal to height of my image over the height of my object, which is equal to the negative of the distance to my image over the distance to my object. When I solve this for the height of my image, then height of my image is going to be equal to the negative of the height of my object divided by the distance to my image over the distance to my object. I'm going to jump down here where I have some room. So the height of my image is equal to negative positive 4 multiplied by the distance to my image, which is, we decided a second ago, is 26, over the distance to my object, which I looked up earlier was 15. So the height of my object, 4 times 26, divided by 15. I've got a problem. My problem is that I've got a negative out here, and my number is coming out to be 6.9. So, okay, I'm going to go with it. Negative 6.9. Okay, what is the problem here? So let's see how close this was. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Oh my God. And as far as the height goes, 1, 2, 3, 4, 5, 6, almost a 7. I would say that we have a 100% accurate drawing. It actually agrees with the calculation. I don't think I have ever seen that happen before. Don't expect that to happen for your drawings. Let's summarize what our conditions are here, and then we can turn this off. When we are between the center point and the focal point, when our object is there, what we find is that we get an image which is real. Again, real means that the distance to my object is, distance to my image is positive. It is enlarged. It's definitely bigger, which means that the absolute value of my magnification is not equal to, it's greater than 1. It is inverted, which means that M is negative. That's what this negative 6.9 meant. It was upside down. And the location is the distance to my image is greater than the distance to my center point. We will find that it is located out here, and it will always be located, I go with the parallel ray, somewhere along that parallel ray. Okay? And again, I like the parallel ray the most, and then I like this mid ray. They do a very good job of giving us a quick approximation. If we had stopped there, we still would have had accurate answers. Thank you for watching.